Excellent. Thanks for the tech help, everyone. And thank you so much for the introduction and the invitation to be here speaking to you. I last gave a talk at ADC, I believe in 2016, when machine learning was just coming on the horizon for a lot of the work that people in this room do. And so much has happened since then. So I've made a sort of updated talk. I want to share with you my reflections on human and machine creativity, especially thinking about the technology that's come up in the last few years, and also the technology that's maybe been around for a while, but's continuing to make new and exciting impacts. So I'm going to talk about some benefits and opportunities of machine learning, especially focusing on supporting human creativity in music and beyond. I also want to talk about some of the challenges and caveats that we've got to confront if we really want to realize these opportunities. But I'm going to start out actually with my 3-slide introduction to what is machine learning, because I'm sure everybody here has heard of it, everybody has ideas about it, but not everybody is really on the same page around what machine learning is at the end of the day, what its capabilities are, and what it isn't as well. So here's my 3-slide introduction. Using cats and dogs in music. So machine learning, my definition is it's a set of tools for finding and using patterns in data, right? That's the most simple definition that I can distill for you. And if you imagine that, for instance, you own an online record shop, let's say, we've got customers who are purchasing things from your store and you might have information about them. You could use one type of machine learning to find that some customers are similar to each other, other customers are maybe similar to each other, but they're different clusters, right? Machine learning can do this. We can use machine learning to find patterns to make predictions about your data. So if you say, oh, these customers on the left, they all bought this particular album, and these customers on the right, they all bought this particular album, you might see a new customer that maybe you have some data about and recognize, well, I predict that they're likely to like this album as well. Maybe I recommend that to them. And of course, a lot of the attention in the last 5 years and a little bit longer now is on machine learning algorithms that can use patterns in data to generate new content that's similar but not identical to content that they've seen in the past. So if we recognize that, yeah, these are just pictures of cats, we could collect thousands of pictures of cats, give them to a generative algorithm, and generate new pictures of cats. And of course, the machine learning doesn't think about these as pictures of cats, but it thinks about, well, there are particular patterns that occur over and over, these, things kind of on the top of the image and these other circle things in the middle of the image. And we can compose these together in ways that at the end of the day look surprisingly believable. All right, so that's machine learning. Let's start from that. Forget anything else about it. It's not intelligent. We'll talk about that. It's about patterns in data and how we can use them and why we might want to use them. So the next part of my talk is, what are the benefits and opportunities for these types of algorithms for human creative work? And in my own work and the work of my students, often we're not quite so interested in, can machines make art? Can machines make music? But rather thinking about, how do these algorithms change what we can make, how we make it, and who can participate in this? So the first benefit I want to talk about is kind of like the boring one, but often super, super important. And it's often overlooked in a lot of the hype about generative algorithms today. Machine learning is a great tool for making sense of data. And people in music, whether you're talking about consumers, creators, companies, students, people have data just like we have data in finance and in healthcare and in other domains where, hey, it's valuable if we can make sense of that data somehow. This is a word cloud I made from some of the ISMIR 2021 topics. ISMIR is probably the main conference where people publish papers about how you can use machine learning to make sense of music data, whether audio data or data about listening or score data and so on. And there's so much machine learning doing cool stuff here, helping us make sense of music through things like transcription, aligning audio and lyrics, identifying what kind of genre or style or mood is present in an audio file, and so many other things, right? These are important things for a lot of people to do, and machine learning makes them possible. When I started working with music and machine learning in about 2004, I was working in this space. I got really excited about how we could do new things with data. But a couple years later, I'm a musician myself, and I became really interested in how musicians could use these same kinds of algorithms, these same kinds of techniques to make new things for live performance and for composition. And at that point in time, there was an increasing availability of sensors and APIs that allowed people to get really interesting data from the world about, say, how somebody is moving with a sensor, or what data might be coming in from a camera or microphone. And musicians have been interested in using this kind of data to make new music for decades previously. But a lot of people who were making those systems actually had PhDs in computer science or electrical engineering. They had a lot of digital signal processing and computation and sometimes machine learning expertise. But for the most part, musicians without that expertise were locked out of making the more complicated, interesting things. And so at that point, we're talking about 2008 or so when I started this line of work, getting data from the world that you might use in live performance was increasingly easy, but interpreting this data, saying something useful about what a person is doing on stage, what kinds of sounds are happening. This was difficult and annoying. And of course, this is difficult and annoying even for people with DSP and programming expertise if you don't use some kind of machine learning for your data analysis. And so at that point, I started building a tool, which ended up being Wekinator, which is a piece of software that simply wraps machine learning algorithms in a user interface that's tailored to the kinds of things that musicians around me wanted to do. So things like building new gestural musical instruments, where you might say, hey, I want to control sound, and as I move my hand, I want the sound to change. And I'm going to use a machine learning algorithm to build this from examples. So I give an example of, hey, when my hand is here, please make this sound. And when my hand is here, please make this other sound. And using an appropriate algorithm, we can build a model that's capable of looking at new data coming in, capturing my motions or gestures, and then outputting predictions, right? This is a classic prediction problem, really, predicting what kind of sound do I want to make as a performer in this moment. And of course, people have been building these kinds of model functions by hand, writing programming code for decades and decades. It's no fun. It's a lot of if then else statements, it's a lot of thresholding, and it's a brittle process. So machine learning can make this a lot more accurate, a lot more effective, and faster. And so because this ended up being useful for a lot of the composers and musicians I was working with, I've continued to develop the software. It's also informed a lot of my research in the last decade or so. Most recent version of the software has about 50,000 users. They're making everything from new gestural musical controllers to new interactive art pieces, new kinds of like digital puppetry. There's been a bunch of startups that have used Wekinator to build their prototypes before going on and doing some more bespoke machine learning solutions. And again, this is all about just making data more useful and more accessible to the people who have good ideas about what they want to do with it. I've taken these ideas and used them in a whole bunch of other projects. I'm not going to talk about most of those, but I will mention that the most recent one is a tool called Interrectamel. This has just been released right now. It's in the process of getting cleared for both Unity and Unreal. This was made with a great team of collaborators. And this is for people to use game engines to build new gestural control, to build things as well like audio analysis that might drive the parameters of a game or some kind of interactions in a virtual world. So I'm really excited about this. There's so much room to make data analysis tools more accessible to creators in a lot of domains. All right, second benefit is maybe the least surprising. Maybe you came here to hear about this. Modern deep learning techniques make it increasingly possible to leverage patterns in data to support more powerful and more intuitive data manipulation. And this is exciting. So I'm going to ground the next part of my talk in some concrete examples. This is hopefully helpful for people who haven't really dived into machine learning before. And let's just start with images because they're easy to talk about, and then we'll move on to audio and other stuff. So imagine, for instance, we want to generate an image, and it's 100 by 100 pixels, right? And we're just going to stick with grayscale. So we can specify any particular image with 100,000 coordinates, right? 100,000 values. And we can think of those as coordinates in a 100,000 dimensional space. So we've got a point in that space. And if we just randomly pick a point in this space, it's probably most likely just going to be like random noise. And if we pick another point, it's just going to be like random noise. So this isn't a great generation approach. But if we have a lot of images and we have an appropriate machine learning algorithm, we can start to detect patterns in, say, photos of real-world objects. And of course, photos of real-world objects are going to live in a really small part of this space. And we can think about modeling that part of the space where we have real-world objects as a lower dimensional space. We can think about this as a sort of manifold in that space. We can talk about this as an embedding, or we could call this a latent space, right? So have this picture in mind. I'm going to be talking about this a bunch. And one of the nice things about latent space, as I mentioned, is we can think about, all right, we can represent most, maybe all, right, realistic images, things that are like the stuff in our data set. We can represent it as just a point in this much smaller space that's easy to work with. So if I have, a picture of a cat, maybe it lives at that point in the space. And I also have really nice organizational properties in this space. So I might have another cat, which is kind of close by, and maybe dogs live kind of, over there, and airplanes live like really far away, right? If I have a function that's capable of translating back from this lower dimensional space, or this latent vector, into the space of actual pixels, then I can do generation. So I might pick a new space, or pick a new point, and I could generate a new cat that's never been seen or photographed before, right? And part of the power here is if you have, again, enough data and an appropriate learning algorithm, you can do this in ways that, even fool people who are used to looking at cats and very picky about what cats should look like. All right, so let's talk about music. I would say that the state of the art at the moment in doing music generation with audio is OpenAI's Jukebox. Who here knows about Jukebox? A lot of people, excellent. I'm gonna play my favorite Jukebox song. This is Hot Tub Christmas with Frank Sinatra. Here we go.
It's Christmas time and you know what that means. Oh, it's hot tub time. As I like the tree this year will be inside. Oh, it's hot tub time.
The display just cannot handle this. While we figure out what's going on with that, I'll unplug and replug this in, see if that works. This is like super impressive, right? This is amazing. Obviously, this is not a Frank Sinatra recording. The human involvement in this process really predates the machine learning component of it, right? So people are using this AI system, this machine learning system called Jukebox, which has essentially learned out of the space of, millions, billions, trillions of possible audio waveforms, where are the waveforms that actually sound like recognizable music? And furthermore, like, where do you need to be in that space to get stuff that sounds like Frank Sinatra? And furthermore, for this particular system, you can do something called conditioning on lyrics. So they gave the lyrics that you see on screen to Jukebox, and we're able to generate this for these specific lyrics, right? So it's a slightly more complicated version of what I showed you here, but it's still, we've got a lot of data, and we've learned within Jukebox, where does realistic music live, and how do we then find a point in that space and then generate an audio waveform? And it's amazing, right? This is like, I would not have believed 5 years ago that this was going to be possible in 2020 when this came out. All right, and we don't just have to think about this with image. It works for audio, it works for MIDI, it works for video, it works for text. There's super exciting stuff happening in text, including, of course, GPT-3, which I assume a lot of people have heard about, maybe played around with variants of this. This made a big splash when it came out in about May 2020. This is another transformer, same kind of algorithm used for Jukebox, trained on billions and billions of documents from the web. So lots of web pages. And it's learned what kinds of patterns of characters end up giving us text that's realistically human, written in English about various topics. And sort of like telling Jukebox, hey, I want a Frank Sinatra song and here's the lyrics, you can also take this pre-trained model and give it hints about how you want it to generate something. You can give it a prompt and you can say something like, write me an editorial as if it were, appearing in The Guardian and written by AI. And that's exactly what The Guardian did. And you can read this and it's pretty impressive, right? Similarly impressive as the Frank Sinatra music. It really does look at first glance and probably second glance and third glance that it's been written by a person, right? So all sorts of powerful stuff here. But what else can we do besides just generating stuff? Well, we can manipulate content in really interesting ways. So we can morph content by starting with one point in this space and saying, I want to start with this face and I want to get to this face. And that is at this point in the space. And I can kind of walk along that space and generate some realistic transformations where every point there looks like it could be a human face, even though none of these are real. Now, I mentioned this when I gave my talk in 2016 as something that was super exciting, but at that point it was really just expert programmers and expert machine learning people who could make this work. And since then we've seen some actual tools that give people the ability to do this, which is super cool. Google Nsynth is one example. If you haven't seen this is a few years old now already. But this is essentially just finding that organ point in the space and the electric guitar point and walking between them. This is what this sounds like. Right? And you don't have to just do this with audio snippets. You could do this with melodies. You could do this with drum loops. And Google Magenta has been one of the main research groups playing with this kind of techniques, developing these kinds of techniques for music and audio. And they've actually released several of these within the Magenta Studio tool. So you can play around with these. They're an Ableton plugin. Also, you can just use it to generate MIDI. So definitely worth playing with. Another thing you can do here, of course, is find meaningful directions in the space, where you might say, well, this face lives at this point, and if I move this way, I discover I can make the face smile more. Or if I move in the opposite direction, maybe it becomes more serious. And again, this is something I talked about in 2016. It was just something for like coding nerds with a lot of compute power and time to play around with this. But now, just a couple months ago, this has been released in Adobe Neural filters. So you can take a photo of a person, you get some sliders that control things like happiness or age and head tilt, and you can do very compelling, if not totally perfect, manipulations of these faces. And you can play around with other tools as well. If you're not a pro Adobe user, there's weird stuff you can do. Same kind of idea on ArtBreeder. I stuck my headshot into this and was able to make these variations in just a few minutes. And of course, these kinds of transformations are becoming more possible and more accessible for all sorts of media. So this is coming into, I think, a lot of tools. Another variation of stuff that people are finding cool as researchers and making kind of research demos that is, I think going to be making it into more products is transferring some aspects of style. And I don't mean style transfer, the classic deep learning paper from a few years ago, but saying, hey, maybe I've got a selfie, I want to turn that into an anime character, and I want to transfer the style or presentation, the superficial aspects of this image onto the structure and positioning of this image. So you can do this with anime, and of course you can also do this with other content, and the Google Tone Transfer project is an example of doing this with sound. So instead of faces, you could start with a melody and say, render me this melody that I've just sung, but play it as a flute. So that's what this sounds like right here.
Whatever would that sound like? That's beautiful.
All right. So there's so many examples like this that I could share. I could give an entire talk or probably 3 different talks all about cool things that people are doing that are changing potentially what we can do with media. But why does this all matter? Well, I've got a few reasons why I think this matters and a few things that get me really excited about this space. And the first one is that people are increasingly able to use machine learning tools to improve accessibility of creation. This goes for, say, musical or creative novices, people who aren't programmers, and all sorts of other folks. So I'll give you some examples. I think a now classic example in the audio programming space would be Lander. Anybody here from Lander? Awesome. You guys are cool. Lander uses a sort of machine learning workflow that's increasingly common across a lot of tools now, where you say, okay, I'm going to use machine learning to capture some expertise of human experts. I'm going to train on data that's been created by experts somehow, whether intentionally or as a sort of byproduct of them doing their work. I'm going to train a model on that and encapsulate what experts would do, and then allow other people to use that model, right? So in Lander, you could say, all right, now anybody can upload a music track and have it mastered the way that an expert might master, or at least mastered in the way that a machine learning model pretending to be an expert might do it, which is still probably going to be way better than what most people would do if they're not trained to do this. This same kind of workflow of machine learning, as I mentioned, I think this is present in a lot of other tools and is really powerful. One of my other favorite examples here is this blob opera. If you haven't played with this, like, go play with blob opera. Just leave my talk now and go play with blob opera because it's fun. Here, I'll just show you what's happening and then I'll explain. So here I'm going to drag on one of these blobs. The blob is going to sing, and the blob is going to be accompanied in real time by the other 3 singer blobs. Right? Super cool, super fun. And we've got, yeah, right? This is super fun. We've got 2 kinds of expertise here that are captured in 2 different types of models. One is the actual singers, right? This is singing synthesis that's been generated from data from real human singers. And so I can't sing, I'm never gonna sound like this, but I can now control the singing voice of somebody who actually sounds good, which is cool. But also, of course, you have this real-time harmonization, and the data for harmonization comes from a body of, sort of particular classical music that has these harmonies in it, right? So I don't have to know anything about music theory to be able to render something that actually sounds convincingly like it lives in that genre. And I can do this, in 10 seconds, as you saw. All right, so this is this model of saying, yeah, let's train models on experts and then let other people use them. Super fun, but also not, by far, not the only thing that we could do. I have a project that just wrapped up a couple years ago called Sound Control. And in this project, the idea was that we're not going to try to make people make music like experts. We want to help people make music the way they want to make music. And the collaborators on this project included some music therapists and music teachers who were working with kids with a variety of disabilities. And they were really excited about the potential to make new musical instruments and new musical interactions with these kids. And so they had a Wekinator-like interface where they could show gestures and say, hey, this is how we want to move, or this is how this kid wants to move to play some music, and also here are the sounds that the kid wants to make. And then that data is captured from them on the spot. A model is built from that on the spot, and immediately they have an instrument that they can play with. So it's not about making them sound like classical opera singers. Often the kinds of sounds they wanted to make were like animal noises or fart noises. But that was actually much more fun and useful in this context. I will mention one of the collaborators on this project is Martin Townley, who's here. Wave your hand. He's looking for jobs, and you should hire him because he was really awesome. All right. Another kind of workflow that I want to mention is, again, something that I think we're going to start seeing in interesting places in the broad field of creative practice or creating things using technology. So this is an interface built on top of GPT-3. As I mentioned, GPT-3 is a pre-trained model. None of us in this room have the ability to train our own GPT-3. It's way too expensive. But we can take a pre-trained model and we can give it some additional information about what we want it to generate. This is called Fewshot learning or one-shot learning, or you can even do zero-shot learning. In this example of, say, Fewshot learning, a designer, not necessarily the end user of this product, but a designer has said, hey, I want to build a thing, and I want people to be able to type in English descriptions of a web page, and I want this thing to output the HTML for that web page, right? And they can give some examples of like, hey, here's a red button, and here's HTML for that red button. Here's a title text, here's the HTML for that. And after the designer gives some examples, they can then put a nice interface over all of this and give this to an end user who then types in some descriptions, which might look very different from the descriptions that the designer has used to prompt the model. But nevertheless, because this model is built on billions of text pages from the internet, it has a good model of language, and it's just got a little bit of hint of how to connect that to HTML, we can get some cool results. So here's an example. So this is a person, end user types in a button that looks like a watermelon. And there we go, button that looks like a watermelon. Large text that says, welcome to my newsletter, and a blue button that says, subscribe. And here it makes a mistake. It makes this text white by default. The person can go back and say, text in red, please. And now it's generated the text in red. And it can do stuff that is absolutely not in the designer's set of prompts, like a button for every color of the rainbow. And here we go. We got a button for every color of the rainbow and the HTML for creating that. And you can go online and see examples of people doing this kind of thing in all sorts of other contexts, often programming contexts. You can see examples of people doing React programming with this. You can see examples of people doing Figma for user interface mockups. This is a really powerful paradigm, I would say, for a few groups of people. You could imagine this making design processes for experts much faster. You could imagine this making design accessible to novices. And you can imagine this being a really nice learning tool for somebody who's maybe trying to learn HTML or React, who, maybe this isn't the end product, but it gives them a starting point that they can then tweak. All right. The next benefit I want to discuss is how we can enable completely new forms of expressive work. And I've got 3 creative projects here to share with you. The first one is one of my favorite people working with Wekinator. This is Letitia Tsunami. And she's built this instrument with Wekinator called Springspire. And what you see on screen here is 3 metal springs, each of which is attached to an audio pickup, but you're not hearing the audio from these pickups. These pickups go through a set of a few dozen bandpass filters, and the values from those bandpass filters are actually being sent to Wekinator as inputs into a predictive machine learning model, a set of predictive machine learning models. And the outputs of those several dozen models then go into controlling a whole bunch of synthesis objects in MaxMSP. So this is a really cool instrument that you absolutely could not build without machine learning, because it's just too crazy of a programming problem. So I'll pause that there. Very cool piece, totally fun. Next piece I'm going to show you is by Mario Klingemann, somebody who's doing great, interesting work with machine learning in the creative space. And here what he's got to generate the images, he's using a type of GAN, which again builds this sort of latent space of images, and you can generate new images in different points in this space. And he's kind of walking around this space, and the directions that he walks and the locations that he, the jump sizes that he takes are determined in real time by features of the music, right? Things like, I would imagine, RMS or bandpass outputs from the music playing. So take a look at this. super weird. Oh, good. All right. The last piece, creative piece I want to show you is some work by Memo Atkin. Again, one of my absolute favorite people working in this space, someone I had the privilege to work with a bit while he was a PhD student at Goldsmiths. And this is his project called Learning to See. And what he's got here, I'll turn the volume off on this so I can talk over it. He's got a type of generative model generating the images that you see on the right. And what you see on the left is the input to his webcam. And what he's doing is sort of, telling the machine learning model, try your best to recreate the stuff that you see here on the left, but only using the kinds of images that you've been trained on, because that's all you know about. And so the first model here is a model of seascapes. And it's, I think, beautiful, and this is all real time. He's built this as an interactive instrument, so you can play around with it and watch the images change as you move. He's got another model later on in this video, which is somewhere here, fire. Let me give you some fire, which is super cool. And he's just taking random stuff from his desk to make these beautiful fire images. And another model later on, which is flowers. So I really like this project. Again, totally not something you could make without machine learning. And the last benefit I want to talk about is how machine learning can enable new creative relationships between people and machines, not just changing what they make, but how they make and even how they think about themselves in the creative process. I asked Letitia one day, can you explain why you choose to use machine learning in your work? There's all sorts of other things you could do instead. In Springspire, I think it's useful to know that she's using regression to make this. This isn't a generative model, it's a predictive model, but she's using regression, which means that she can give it some examples of, one gesture in one sound and another gesture in another sound, but then she can make gestures that aren't exactly equal to either of those, and she'll get sounds that might be in between or outside of those sounds. And she says, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and leaving it at that. So for her, this is, I think, a much more interesting process than just saying, well, I've got a bunch of triggers, and they're going to make some noise, and I'll be done. Another artist I'm a big fan of is Anna Ridler. She has a video piece called Fall of the House of Usher, where she took an old black and white film, Fall of the House of Usher, and took the first part of that film and hand drew black and white renditions of stills from the film. She trained a machine learning model to generate images in that style. And similar to the work that I just showed from Memo Atkin, she then showed it the whole film and said, frame by frame, all right, use this model to regenerate images in my style. And she's got a great blog post about this work that I've linked to on the bottom, writing, the idea of control is misleading. It is impossible to predict what will come out. I can guess, but I cannot know. The errors and choices that are made when I'm drawing are amplified, and the GAN holds a mirror up to my own drawing and makes me realize things that I was not aware of, what I find the most important, what I always edit out. It is my work, but also not my work, recognizably me, but nothing I would have been able to do by myself. Watching it is a very odd sensation, like catching a glimpse of yourself in a mirror before you realize it is you. And again, who doesn't want this kind of experience in a creative process, at least here and there? This sounds, really exciting and really new and potentially really powerful. Last thing I want to talk about changing practice comes from some PhD work by a student of mine, Nato Tella. This isn't published yet, but he's done a study where people were improvising with AI, doing these jam sessions. It was one person, one AI, and they were interviewed afterwards. And they talked about things like, the fact that they were playing with an AI gave them freedom to venture places they might not go with a human collaborator. They could play without prejudice to their collaborator. And they had a sort of safe space in which they wouldn't be judged, and they could do maybe more adventurous things, more risky things. Interestingly, these people were not playing with an AI collaborator. They were playing with another musician in another room. They just didn't know it at that time. And when we revealed to them that actually, Joe here was playing the music, not an AI, some people were quite upset by this because, they'd really transformed into sort of different people that, showed a musical side of themselves that they weren't willing to show with the person. So again, I think this has interesting implications for what it might be to improvise or perform or create with AI systems of the future. All right, so what are the challenges? What are the caveats? What are the things we need to really consider and grapple with if we're going to realize all the benefits that I just talked about? I'll start with a really practical one, which is that steering a lot of these generative models, a lot of these really exciting state-of-the-art systems can be super hard or even impossible, making them difficult to use in a lot of contexts as real creative tools for people. So if I had Hot Tub Christmas and I wanted to say, Frank, this is great, but can you start it a little slower? And can you please, transpose this to F? And also the trumpets, I want them to be punchier, right? There's no way for me to do any of that. I'm stuck with what I've got. I can choose a different random seed maybe and generate again, but that's all I can do. This is a big active area of research in machine learning right now. And of course, there have been advances even in the last few months leading to the ability of Adobe to produce a product like the Neuro filters that actually does give people sliders with some degree of reasonable control that makes this necessary if you're going to use this for anything at all. There's also been some really exciting advances around coupling natural language models to control content generation. And this is something I think, again, we're going to see a lot more of this in interesting ways in the next few years. The most recent example of this is called Clip, which models images and text simultaneously. And you can use this paired with an image generator like VQGAN to say, all right, I'm going to give a description like houseplants in the style of Van Gogh, and I get an image that actually looks like that. So I'll share some of my favorites with you. This is generated from the prompt Radiohead crossing Abbey Road. This is draw me Mariah Carey's All I Want for Christmas Is You in the style of Norman Rockwell, MC Escher, and H.R. Giger. And this one is Scary 9 Inch Nails tribute band performing on stage Unreal Engine. So this is pretty cool. Unfortunately, even these models are still currently really hard to control. So it's not like I can look at this and then edit the prompt and say, well, I want one more guy on stage and I want the lighting to be brighter and so on, right? You can't really do that. And you see in this prompt, we've got this text at the end, Unreal Engine, which is a hack that some artists discovered you could put at the end of your description and the model would try to render your images in like a higher quality. Yeah, funny, right? Of course, artists and musicians aren't just sitting around waiting for benevolent machine learning researchers to gift them with new algorithms that do what they want. There's some really interesting innovation happening, of people just saying, well, what can we do with what we have right now to make control and steering easier? A paper by some of my colleagues just came out in March. This is a paper on network bending. And the idea here is that you could take a fairly arbitrary generative machine learning system, maybe for making faces, let's say, and then you could train another neural network to work alongside it. And that second network can learn what the neurons inside your generative network are doing and start to make reasonable predictions about which ones you might want to manipulate if you wanted to achieve certain effects. And then you can just sort of stick your fingers in there and start manipulating those and see what happens. So you could end up being able to like remove a face or change a facial structure or remove eyes, for instance, if all of your eye removing needs. This has been used in a few projects so far. This is a project for the band 0171, where they wanted to commission a series of artworks, one for each of 5 singles on an EP. And they had a design brief, like they wanted these artworks to be thematically similar but unique, and network bending was used to achieve these results, which is pretty cool. The next set of challenges that I want to talk about is this, that big models and big data have big and often really bad consequences. And this is strongly informed by this recent paper by Emily Bender and Timnit Gebru, which made a lot of noise, got a lot of attention in the machine learning community, even before it was published, because about a year ago, this was one of the factors that led to Timnit Gebru being fired from her position as an ethics researcher at Google. And this paper focuses on some of the dangers of large language models like GPT-3, but there are absolutely parallels to models in music, large models like Jukebox, as well as other models that we could imagine making or that have already been made. The first set of things they talk about in this paper are the environmental costs of building large models. There is some research a couple years ago showing that building and tuning one single transformer that was kind of state-of-the-art in like 2018, so nothing near the complexity of GPT-3, even that would have the carbon footprint equivalent to 5 cars over the entire lifetime of those 5 cars. So that's enormous. That's a big problem. What are we going to do with that information? Well, the bad news is nobody's figured out what we're going to do with that, and it's getting worse. Looking at 2012 to 2018, the researchers estimated there had been a 300,000 times increase in the computing power required to build one of the state-of-the-art models, right? And it's gotten much worse since then. Why do we have these costs? Well, in part because if we're trying to build really complex powerful models like GPT-3 or Jukebox, we need a lot of data, right? GPT-3 is billions of web pages, Jukebox is 1 million plus songs, and if we're going to train something on that data, we need a lot of training time. And this brings us to another challenge, which is that it's an increasingly small number of people at an increasingly small number of organizations that actually have the resources to pay the electricity bills for this kind of training, or to build the computing infrastructure for this training. And I think it's useful to consider what does that mean? What might the future look like in 5 to 10 years if it's only, say, 3 companies who have the resources to build the state-of-the-art music generation models, right? What does that mean for creators? What does that mean for people in this room when someone else is making decisions about what music should we model? What music should we not worry about? What do API access and licensing look like, right? Maybe determined by a fairly small number of people. And then, of course, let's talk about training data. In this paper, they give all sorts of good and frankly very scary examples of the implications of training these models on really the only large data sets that we have, which are things scraped from the internet. Representation is one big issue, right? We can get billions of examples of web pages in English. We can't necessarily get billions of web pages in languages where we might have 100,000 speakers or even 1 million speakers. And that means that people who are coming from these minority language groups are not ever going to realize the benefits of models like GPT-3 for their own language, unless we change something big. And of course, those people who speak minority languages are also often people who are likely to bear the brunt of the environmental costs of global warming, right? Big problem here. Also, bias is a big problem. If you're scraping data from the internet doesn't represent everybody, doesn't represent all the views or preferences of people equally. GPT-3 was trained, a lot of its training data comes from Reddit, where you have people with particular demographics, worldviews, particular ideas about gender and race and so on. And you can see this really easily. If you take GPT-3 and or even its predecessors like GPT-2, which you can play with online today, I recommend you do that. You can type in questions like, about Black people or about women or about Jewish people, and it's going to come out with like really, really, really horrible stuff. All right, so what does this mean for us working in music? Music doesn't have bias. Music is a universal language, right? We don't have these problems. Not really. I would say we absolutely have these problems in music, and we haven't really started as a community to grapple with the consequences, with some exceptions. There's been some nice work at Izmir in particular about the consequences of the historic focus on Western music in that community. This is an image from the Jukebox webpage on OpenAI. It's pretty hard to read, I think, but it's sort of a partial map of the music that Jukebox was trained on. And we've got, an R&B here, we've got hip hop, rock, blues. And one of the goals of Jukebox is to capture all these different styles and genres of music in the same latent space. And to do that, again, you need a giant, giant data set. Maybe you get some really powerful things in exchange for that. You could, for instance, say, I want to walk from Rihanna over to Sinatra and like interpolate, and maybe that sounds cool. I don't know. And again, of course, this is using data scraped from the web. Whose music is on the web? Whose music is easily findable by a scraper? Some of it is music that undoubtedly lots of people care about and love, and that's useful, but a lot of people's music is not here. And that means that this model is not going to represent that music. It's not going to be useful in generating music of those styles or analyzing music of those styles and so on. Furthermore, I would say we even have some other challenges in music in that for a lot of machine learning work in music, it's computationally sensible to not work with raw audio. It's a lot easier, you need less data if you work with symbolic representations, things like MIDI. But when you have a symbolic representation, you're throwing out a lot of information. And this could be things like tempo, it could be things like meter. And in fact, if you look at rhythm models from research in the last 5 years or so, almost all the published papers focus only on simple meter, right? You can't do triplets, much less combine triplets and simple meter in the same piece of music, which means that they're absolutely not able to model any of the rhythms from African music, a lot of African music, a lot of Latin music, a lot of contemporary electronic dance music. It's just left out, and there's no way to get it back. So I would say, I'm not saying that Jukebox is not useful. I think it's useful for some things and it's exciting, but I really strongly think that we should be approaching this more broadly and saying, well, what other kinds of models can we build? What other kinds of things could we be focusing on? And with that, I'm going to show you an example of a really cool project that my postdoc, Gabriele Vigliansoni, has been working on. He's a music performer and researcher, and he's got this project that you can go download called RVAE, which constructs a latent space and a rhythm generator from a really small data set. So we're talking like a dozen examples, maybe a couple dozen. These examples can be really, finely hand-picked, right? They might represent just the kinds of sounds that he wants to play in his performance, right? So he's not trying to make Rihanna and Frank Sinatra. Like, why would you want to do that in, an electronic music performance anyway? He's just picking sounds that he likes, making a latent space from them, putting them in an interface that you can control using your mouse. I'll show you a video in a second. And also he's using a data representation that allows for simple and compound meter and mixtures of those. So this is what the interface looks like. Oops, turn my sound back on. All right, so pretty cool. And now I'm going to show you a video of him performing in London a couple weeks ago. All right, so I think this is really fun music. I like this. I want to listen to this. I want to dance to this. And this is, created, again, from just a very small number of examples, no carbon footprint to speak of. It trains almost immediately, and you can make this system work in real-time performance. So you don't have to sit around and wait for hours or longer to generate something from a really big model. So I'll be honest, I think people should be doing more work like this because it's really useful and fun. Third challenge is that I think a lot of folks tend to think about machine learning in the wrong ways. We tend to have a very limited view. And by we, I mean researchers, I mean people in industry, I mean the media. For one thing, I think there's so much focus and hype around generation, in part because it makes for good headlines. People saying, robots are coming to create songs and will musicians be out of a job? And that's like just one piece of this much larger set of things that people care about, right? I've talked already about how machine learning can be useful for making new live performance interfaces and musical instruments. At ISMIR, people are looking at all sorts of music analysis and search and recommendation challenges where machine learning is super useful. And of course, there's lots of creative practices from composition, ideation, jamming, orchestration, DJing, production, where, yeah, it might be helpful to technically have some kind of generative algorithm in there, but the real power can come in how we connect these to human processes and human content. And so, yeah, generation is like one little piece of it, but I don't think it's the exciting piece. The other misconception that I see, which I think has real consequences, is people looking at models, especially current deep learning techniques like GPT-3, and thinking that machine learning is intelligent and the singularity is coming, and wow, we're in this new era of intelligent machines. And this isn't a baseless assumption. When GPT-3 came out, a lot of people were really impressed, as was I, at how it could do really complicated tasks like question answering. This is a question from like a medical textbook kind of exam, and GPT-3 was able to choose the right answer and give a coherent explanation for what was happening. And unfortunately, this is super cool, but this is not intelligent, right? If you ask GPT-3, how many eyes does a horse have? These are some of the answers you get. 4, 1 in the front and 3 in the rear. Or 4, it has 2 eyes on the outside and 2 eyes on the inside. I don't want to see these horses. I don't want to meet these horses, right? The singularity is not here, folks. And I think, if we start to tell these stories about machine intelligence is coming and we're really close to it, first of all, we're going to forget that these kinds of mistakes are going to be made, right? And there are going to be musical equivalents of these kinds of mistakes, even in cutting-edge music systems. And it's good at least to be aware of that and take that into account when we're testing a system before deploying it, or when we realize we have to engineer around some of these things to make a compelling performance. And also, of course, when we start to really find the mistakes that systems make, that tells us what research is there left to do. What are the problems that are still there to be solved? The final challenge I want to talk about is the fact that working with machine learning is just harder than it needs to be. I've already talked about how training machine learning can it's becoming increasingly exclusive to people with lots of resources if you're talking about state-of-the-art big deep learning models. And that's a problem. But even ignoring that for the moment, here's some code that I use with my students frequently. This is from the Keras tutorial on DC GANs. And here's the code. This is totally not the whole code. This is just the code you have to write to override the train function in Keras to build this GAN. And Keras is supposed to be like one of the most user-friendly, easy beginner sorts of deep learning tools. This is painful, right? I try to teach this to students who've only been coding for a few months or a year, and they deal with it, but this is not fun for them. This is not putting them in a creative space, and this is not something that they're going to sit down and suddenly want to make a lot of art with. This is changing a little bit. There have been really nice examples of people taking research and bundling it up into tools that don't prescribe exactly the kind of music or art that somebody should make, but actually do give creators a fair amount of expressive leeway. One of the early tools, and I think still best examples of this, is Magenta Studio, where again, the researchers from Magenta bundled up a bunch of their research into Ableton Live plugins. And you can play with these. Highly recommend that you play with these if you haven't already. Another nice example is called Runway ML. They're transitioning a bit to be sort of like a video editing company, but at various iterations of their life as a startup, they've made some really cool, friendly tools for artists and sort of experimental video and art people to use algorithms in ways that allow them to do totally new things without having to be machine learning experts and Keras programming experts and so on. And as I mentioned, this is something that I've been really interested in my own tools. Interrectamel, for instance, we use a data flow programming paradigm that fits in really nicely to Unity and Unreal, with our goal being, hey, let's not just allow software developers to make new machine learning systems, but let's allow designers to make prototypes. Let's allow VR artists to do this. And actually, those are the people often who are going to have the really good ideas, and giving the ability to them to prototype and iterate on their own without a developer right next to them is actually going to advance those ideas much more quickly. And I will also mention the set of learning resources out there is growing in a way that makes me really happy. I've had a MOOC on machine learning for creative work on Cadenze for many years now. More recently, I've been involved in some MOOCs with FutureLearn. Dan Schiffman has some great resources, especially for students or people who are just starting to program in JavaScript. And there's a few books out there, textbooks, about machine learning that are helpful, practical, but not targeting people who are primarily programmers, but people like designers for whom it's really valuable for them to understand what these algorithms are capable of, how they might develop new products using them. So this is changing, thankfully. All right, I want to finish up with a summary. So I talked about first benefits and opportunities for machine learning in creative work. First of all, machine learning can help us make sense of data. Don't forget that. It's still a big thing. Machine learning can help us leverage patterns in data to support more powerful and intuitive types of data manipulation. It can improve accessibility of creation for novices, non-programmers, and others. It can enable completely new forms of expressive work, and it can enable new creative relationships between people and machines. On the other hand, steering generative models can be really hard. Big models and big data can have really bad consequences that we're only now starting to recognize, and nobody's really come to grips with how we should approach these. We often think about machine learning in the wrong ways, where there's a focus on autonomous generation, and people mistake machine learning for intelligence when it's really not. And I think this leads to people not seeing all the opportunities that are out there. And of course, working with machine learning is harder than it needs to be, which means that some of the people with the best ideas, who are best positioned to understand what transformative things could be built, they're not using it, and they're not developing expertise with it, and we're stuck. By the way, this is me using VQGAN plus clip to generate a horse with many eyes. All right, so I've got 3 invitations to leave you with if you found anything in this talk interesting or inspiring. First of all, I invite you to try out machine learning for yourself. I know a bunch of people here are doing stuff with ML, that's great. If you're not, you have no excuse. It's never been easier to learn something. At the top here, I've got the resources I recommend to my students, including people who might not be programmers or who might be beginning programmers, including people who really hate math. These are nice tools to start out with. If you're an expert programmer, if you're a mathy person, you've got no excuse at all. There's all the MOOCs you could want out there. And I tell my students, starting with Keras and Colab with Colab tutorials is pretty easy. You'll get up and running in a couple hours. Second invitation is I invite you to tune in to the research that's happening in this space, because it impacts on so many things that people in this room could potentially build, or who are things you're currently building. On the academic conference end, NeurIPS is the place where all the top machine learning research gets published. But also there's conferences like KEY, the Human Computer Interaction Conference, where I just spent 12 hours last week on a program committee for computational interaction at KEY, where for the second year now, there's an entire track of papers around exploring how might we make better interactions with machine learning. What is machine learning good for in human context across all sorts of domains? And how do we help designers learn how to work with it, for example? In the middle of these is the IUI, or Intelligent User Interfaces Conference. And all the stuff on the bottom here is stuff that intersects with music, people doing creative work as well as music analysis work at Izmir. My other top tip is that there's this awesome news digest called Import AI at jackclark.net. Jack Clark is the former policy director of OpenAI, so he really knows this field, he knows what he's talking about, and if you sign up, he'll send you every week a nice newsletter with the top headlines from AI research around the world, and it's put into context in a really accessible way. Of course, there's also a lot of great and increasingly large set of books about machine learning that aren't for technical learning about machine learning, but rather try to paint the big picture, or try to give you more critical engagement with the technology that's being built. So these are my top recommendations in that space. My final invitation to you is think big when it comes to machine learning and how it might impact on the work that you're doing, but also how the work that you're doing might start to intersect with the other conversations that people are having in this field. Obviously, audio is at the core. It's probably pretty obvious to you now, like what machine learning can do with audio, what technically might be possible in the space of audio samples. But beyond that, of course, there's all sorts of other stuff where machine learning is increasingly critical and transformative, not just business intelligence, but the way people design hardware and software, user experience of systems. Beyond that, I've talked about new forms of music becoming possible, new interactions becoming possible. I didn't even get to talk about GitHub Copilot, but developer experience is potentially changing with new tools. And then outside that, as I've discussed, there's all sorts of big questions about how machine learning intersects with participation, inclusion, ethics, environment, learning, things that probably many of you care about deeply. So that is the end of my talk. I'm very happy to answer questions, and it's been a pleasure speaking to you.
Hi.
Hi.
I was wondering if you had any thoughts about getting quality versus quantity of data, because you mentioned some of the smaller models that are doing interesting stuff, but also you've got the huge models that do really interesting stuff, but also are scrubbing from Reddit.
Yes, and I think this is a debate that's going on in all sorts of applied machine learning fields. And one thing I can say is, just computationally, practically, if you're going to be learning from very small data, then quality really matters. And even things like data representation really matter. And maybe you don't want to be using even deep learning. Maybe you want to be using shallow learning with really good feature representations of your data. But if you can do that, you can often do really powerful stuff that's really tailored to something specific. I also think, and Emily Bender and Timnit Gebru talk about this in their paper, that there's for a while been this sort of assumption amongst a lot of machine learning researchers that if you have data at enormous scale, then quality doesn't matter. And they're making the argument, I think very effectively, that yeah, it does. If a lot of your data is from Reddit, there are quality issues there. You're going to end up with models that are biased in certain ways, offensive in certain ways. And we need to think about how to continue doing quality control at the level of data rather than just saying, we need to audit the outputs or censor the outputs of models. Because, if these models end up being used in wide varieties of commercial and creative applications, then yeah, we got to address it at the data level. A lot of people making a good argument for that. Good question.
Okay, in more typical applications of ML, generalization is incredibly important. We want our models to generalize well to unseen data. It seems that the situation in creative contexts is less clear-cut. For example, sometimes we want to exploit overfitting as it can produce outcomes which are artistically interesting. What are your thoughts on the generalization in the context of uses of ML?
I love that question. My long answer to that question is I have a Kai 2010 paper that talks about that, because this is something that I absolutely comes up in creative practice. And in fact, I almost put a slide in today about this because I still get into arguments with machine learning researchers all the time about this, where yes, in the broader machine learning world, there's so much focus on saying we need to build models that generalize to new contexts. And that could mean things like, if I've got a gesture recognizer, I need it to generalize well to gestures that it's never seen before. And if you're building, a Fitbit like I've got, then yeah, that's really true. You do want to, accommodate, say, step tracking for people for all sorts of body sizes and gait patterns, even if they haven't been in your training data set. Exactly, right? That's a good thing. But if you're building a gesture recognizer to build a new musical instrument, what does generalization even mean? It turns out that often in practice, if you use an algorithm that tries really hard to generalize and to not overfit, to not pay too much attention to the training examples, each individual example, that can feel really frustrating to you as a user of something like Wekinator. Because often when you're using machine learning as a creator, you're using the training data set as your mode of communication, telling the computer what you want. Like, I want to use exactly these gestures. I want to make exactly these kinds of sounds or whatever, right? And if you have an algorithm that says, yeah, I kind of believe you, but I'm still going to iron out some of the wrinkles in that data for the cause of generalization, that's going to be frustrating to you because it's like the computer isn't listening to you. So absolutely, that is an important distinction that comes up in a lot of creative work. Some creative work is going to still be like building a Fitbit. You want someone else to be able to use your art installation or your instrument without getting frustrated. But some of it, absolutely, generalization and overfitting end up being a very different set of priorities. Yeah, good question.